Alright, so in this video we're going to talk about dividing the functions f of x by g of x and specify any domain restrictions for the following 5 problems. So if we look at our first problem, we have f of x equals 2x plus 5 and g of x equals x minus 6. So again, we're going to divide these two functions, f of x being 2x plus 5, and we're going to divide that by g of x, which is x minus 6. What we want to do now is we want to look at the numerator and the denominator to see if there's anything that we can simplify. And looking at the numerator and the denominator, we see that there's absolutely nothing that we can simplify. So that would be f of x divided by g of x. So now we need to look for any domain restrictions. When we talk about domain restrictions, there are two things that we need to consider. Do we have any square roots? Because we all know that we can't have negative numbers under the square roots. And we also cannot divide by 0. So my denominator cannot equal 0. So knowing that information, I know that my denominator, x minus 6, cannot equal 0. That being said, I need to know what x cannot equal. So if I solve for x, I would simply add 6 to both sides, and I would get x cannot equal 6. So my final answer would be f divided by g is 2x plus 5 divided by x minus 6, and my domain restriction would be x cannot equal 6. Moving on to our second example, we have f of x equals 10x to the 5th and g of x equals 5x to the 3rd. Again, we want to divide these two functions. So we have 10x to the 5th divided by 5x to the 3rd. Now we want to see again if we can simplify this. Well, here 10 divided by 5 would give me 2. And if you remember the rules of your exponents, if you have x to the 5th divided by x to the 3rd, we can simply subtract those exponents. So 5 minus 3 would give me x squared. I've now simplified that, and that would be my answer for f of x divided by g of x. But again, we need to make sure that we look for domain restrictions. Now, if you look at your final answer, there's no square root, there's no denominator, so we don't have any domain restrictions in our final answer. However, we need to look at what we started with. And what we started with was a 5x cubed in the denominator. So again, our denominator, 5x cubed, cannot equal 0. When I solve for x, I would divide both sides by 5 and get x cubed cannot equal 0. In order to solve for x, I would need to take the cubed root of both sides, and I get x cannot equal 0. And this is then my domain restriction for problem number 2. Moving on to problem number 3. Again, f of x, which is x squared minus 25, divided by g of x, which is x minus 5. We always want to look again to see if we can simplify. Look at the numerator. Do you see anything? Well, you should notice that this will factor. This will factor by using the method dots, or difference of two squares. Using your Algebra 1 skills, you should be able to factor this. It will factor into x plus 5 times x minus 5. Now, if you'll notice, we have an x plus 5 times x minus 5 all over an x minus 5. X minus 5 will cancel with x minus 5, and I'll be left with x plus 5. This will be my answer for f of x divided by g of x. But again, we still need to figure out if there's any domain restrictions. Looking at my final answer, again, there's no square root, there's no denominator, so that doesn't have any domain restrictions. But looking at my initial starting point, we do have a denominator that still cannot equal 0. So if we say x minus 5 cannot equal 0, and I solve for x, I would get x cannot equal 5. All right, looking at problem number 4. we have f of x, which is x plus 3, divided by x squared plus 8x plus 15. Again, we need to see if this will simplify in any way. Looking at our denominator, we can see that this should factor using an easy trinomial method. Again, if you are struggling with factoring, you need to make sure you go back and watch the factoring videos on Blackboard. Okay? Again, we're looking for two numbers that will multiply together to give me 15 and add to give me 8. So thinking of numbers that multiply to give me 15, we have 5 times 3 gives me 15, and 5 plus 3 gives me 8. So the denominator will factor into x plus 5 times x plus 3. On the numerator, we still have x plus 3. Again, my x plus 3 in my numerator and denominator will cancel out, and I'll be left with 1 over x plus 5. Again, we now need to talk about domain restrictions, but we need to look at what we started with. Well, what we started with factored into both x plus 5 times x plus 3. So both of these things can now not equal 0. So if I set both of those not equal to 0 and solve for x, I get x cannot equal negative 5 and x cannot equal negative 3. So that would be my domain restriction, and this would be my f of x divided by g of x. Okay, our last example is a little bit different. This says find f divided by g of 4. So now, instead of leaving it as a function, we're now going to substitute in a 4 into my variables. There's two different ways that you can do this. The first method is to first find f divided by g and then plug in 4, and then you can simply start right away with your f function, which we have x squared minus 3x minus 4 over g, which we have is x minus 4. And we can simply plug in anywhere we see an x, we're going to plug in the value of 4. So that would give me 4 squared minus 3 times 4 minus 4 all over 4 minus 4. The problem with that, as you can see, is that my denominator will equal 0, and we cannot have that. Hence, why on problems 1 through 4, we have to simplify and talk about our domain restrictions, because we cannot divide by 0. So instead, what we should do is take my f of x, which again is x squared minus 3x minus 4, divide it by g of x, which is x minus 4, and we need to first simplify this. Again, using trinomials, what times what gives you a negative 4 that adds to give you a negative 3? Well, that would be negative 4 and a positive 1. So the numerator factors into x minus 4 times x plus 1, and then the denominator of x minus 4. We now see that the x minus 4s will cancel, and I'll be left with x plus 1 as my simplified f of x divided by g of x. Now substituting in my x value of 4 into x, I have 4 plus 1, which leaves me with 5. All right, you should now be ready to move on to the quizz's assignment.